Imagine that you're using multiple data stores, one for metadata management, another for full text search, and maybe some graph database. You need to compare data from full text search to graph and maybe update the SQL Server metadata data store. The other day, your manager asks you to validate if all entries that exist in Cosmos DB exist also in inverted index in Elasticsearch. Does it sound familiar to anyone? Which tool are you going to use? Good evening and welcome to this session on Databricks, modern and easy platform for working with all kinds of data and any data store. Nice to meet you. I'm Maria Zakourdaev. I live in Israel. I'm a Microsoft MVP data platform and cloud data architect. I have a hands-on experience with all kinds of databases, columnar, relational, NoSQL, and I worked in all three clouds, Azure Cloud, AWS Cloud, Google Cloud. You can reach me with any of those contacts through Twitter or LinkedIn. Here's my email. And I'm also Data TLV organizer. That's the annual conference in Israel where we talk about everything about the data. You're welcome to submit a session and come over. So Databricks is usually positioned as a tool for data scientists and for machine learning. However, I see this tool, it can empower any data people, depending on how many data stores you need to manage. Because if you need to manage only SQL Server, then you have your management studio and you are all right, you are fine. But if you manage more than one data store, you eventually will need some tool with programming abilities. It doesn't have to be Databricks. It's just I love Databricks, and I think it can cover a lot of challenging tasks that you might have. Databricks empowers data analysts and data engineers and data scientists with collaborative platform that can process any data manually or run automated data pipelines. Modern data warehouses have a long history. They evolved with the time, and MPP architectures like Hadoop allow to handle a lot of data. Warehouses are great for structured data, but modern enterprises, they need to deal with unstructured data, semi-structured data. About a decade ago, companies have begun building data lakes. It's just repositories for raw data. It can be in cloud, it can be on-prem, but it's just, you know, the place where you can put a lot of files in any format. Data lakes are great for storing data, but they lack a lot of critical features. They do not support transactions. It's really hard to mix their appends and reads. There is a lack of concurrency and isolation. There is no data quality enforcement. So new architectures are beginning to emerge that address limitations of data lakes, and they called lake houses. Lake houses have the following features. They implement data structures on the top of low-cost cloud storage, just as data lake used to do, but they're adding more layers that allow transaction support, schema enforcement, and they allow BI tools to use data directly without, you don't have to copy, to have multiple copies of the data. The storage is decoupled from compute, and they support both structures and non-structured data, support machine learning workloads, SQL analytics, and they support streaming. In today's session, you will learn how Databricks architecture helps to process big data And we will learn basic Databricks concepts, terminology, what is Databricks platform, key features. We will talk about typical scenarios where I think Spark and Databricks can fit, and also we'll see how to work with data frames in Apache Spark. As we said, Databricks Lakehouse utilizes cheap cloud storage in main cloud services like AWS and Azure, and also Google. This screenshot is quite old, but Google is also supported. Databricks runtime is a set of applications that run on cluster of machines managed by Databricks. Databricks runtime includes Spark, but it also includes a lot of other components that improve usability and performance of the platform. There is a lot of confusion between data lake and data lake. Data lake, as I said, is just repositories of files, raw data files. Data Lake is an open source storage framework. Data Lake runs on the top of your existing data lake and is fully compatible with Spark APIs. What does it mean? It's just there is a transaction log that is attached to each Parquet file, and this allows us to have transactions, support ACID transactions. There is a scalable metadata handling, and being, a transactional store allows batch data processing, and there are also indexes for fast interactive queries. Data lake houses fit well into medallion architecture, which segments data lake files into 3 categories. Raw data for dirty data, silver for clean and where data is already deduplicated, standardized, nested objects flattened, and all naming conventions enforced, and gold pile where you will have data aggregated and business-specific data marts. This is the medallion data architecture is sort of incremental improvement of data quality, but there are users for each category here, because there are different use cases for each one of them. So Spark has started in 2008. And it was open sourced in 2010, and it grown to become one of the largest open source communities in the world of big data. Spark stands out for its ability to process large volumes of data 100 times faster than other platforms. One of the reasons is because the data is processed in memory. Databricks makes Apache Spark increasingly easy and cost-effective to deploy with no hardware to buy, no software to configure, and you can just enjoy everything that Spark platform gives you. Goal of Spark project was to keep benefits of MapReduce scalable distributed fault-tolerant processing framework while making it more efficient and easy to use. Its general purpose distributed data processing engine. On the top of the engine, on the top of cloud storage, there is libraries for SQL, machine learning, graph computation, and stream processing. Besides Data Lake, besides Spark, there is another package that I really like. This is also branded as the machine learning lifecycle management package, but it's an open source platform. It takes care of the whole machine learning lifecycle. But what it can do for data engineers, imagine that every time you run your code, MLflow repository is storing your code, your data, configuration, variables, and results. So you can come and compare your executions. Besides that, it can deploy machine learning models and everything, but it's more for data scientists. As we are now on this session for data engineers, I think this is really nice feature for data engineers, really nice platform for data engineers to compare executions of the same code. So we talked about Data Lake, Spark, MLflow. There are a few other packages that are included in Databricks runtime. TensorFlow is an open source framework created by Google, and PyTorch, open source framework created by Facebook. They are used mainly to create real-time models for machine learning. And I'm not really a person for machine learning, so I will stop here. And we're not going to focus on this part of the Databricks runtime. Besides that, on the top of Databricks runtime, we have Databricks Workspace, which contains collaborative notebooks and workflows. A collaborative notebook is a web interface to Python or SQL file. Depends which language you're going to use, and we will have the demo in a second where you can see how you can change it. And this web-based interface contains runnable code. It can contain visualizations and narrative text. Databricks notebooks support GitHub as a notebook's version control. You can always go back and see every version of your notebook, the things that you have changed, and amazing collaboration. It's real-time co-authoring, commenting, and you can work together on the same notebook at the same time and immediately see changes that other people do. And we can schedule notebook executions using workflows. It's sort of extract, transform, and load the ETL workload on schedule. Can be large multitask flows. Well, we will talk about the Databricks place in all Azure, between all Azure services. It's definitely not orchestrator services. You can run flows and schedule flows, but that's not its main feature. It's like side feature from my point of view. Okay, and there is a Unity catalog for fine-grained governance. We can have fine-grained permissions on tables, views, MLflow packages, uniform permissions, auditing, and all things that you need to have really governed platform. Okay. If anyone has any questions, I will go to them.
There currently are no questions.
All right. Okay. I hope my cluster hasn't died. All right, it's not. Okay, this is the notebook. We can have a different kind of cells in the notebook. It can be markdown cell, which contain text that we want to display, narrative text and all kind of other things, and the code cell. There is a language of the notebook, which can be one of Python, or SQL, or Scala, or R. By default, it will be Python, but you can change it anytime. It's not correct. Okay, so there is some kind of the language, the markdown language, how you can write the narrative text. And we have all kind of examples here, how you do the list and all kind of headings, hyperlinks. You can see it here. This is how it looks. You can click on the hyperlinks, and we even can have the pictures in here. For instance, here is an theory. Okay. We can also write formulas, which is, it looks really nice. Formulas in a markdown cell. There is a whole language for formulas. You can document formulas that you're using for. Okay, now we can write queries. As I said, we can have code cell in Python or in SQL. Here I can change it, and then also can use magic. It's called magic command. Here I state that I will write code in SQL, and there is my simple query. This is just simple query language, SQL language. I will run the cell. It's my cluster. My cluster is terminated. No. Okay, we'll need to wait a little bit. I was talking too long in the cluster. I will show you, meanwhile, the cluster that I am creating. Here in the Databricks UI, we have the workspace where we have all the notebooks that I'm going to show you today. And we have compute here, where we will see the clusters and the workflows. We're going to, if we have enough time, we will see also how workflows work. Okay, so now I'm going to compute, and this is my cluster. Interesting things to keep in mind that you can choose Spark version, access mode, whether it's single user or multiple user, and amount of workers. We're going to talk later about how the cluster is processing the data. It's cluster of Databricks, as I said, is a few machines that are working together to process our data. Here I have 4 workers. I can enable auto scaling and just say start with 2 servers, and if my workload seems big, just auto scale. Here I'm not using it. This is very important. Terminate after 16 minutes of an activity. Otherwise you will pay just for cluster standing and doing nothing. There is a new feature, serverless Spark cluster. It's a bit more expensive, but here you don't have to wait till cluster started, and you can, in a few seconds start using the cluster. I don't have this one set up. Let's see if it's ready. Okay, so I'm going to run this cell. I can run it from here, run cell, or I can do Control Enter. The first cluster warm-up is taking time. And it's not OLTP system, it's for processing big data. Yes, it's not really that, sub-second response time. But you can see we got our data set back in a table as a result set. Okay, we can use Python in other cell, to print things. We can also generate the data frame, and we're going to talk about data frames, but this is just a simple Python code that create data frame, and then I have each row, I just generate the category and product, year, and sales amounts. It's like a table, and then I say display the data set. And
Maria?
Yes.
We currently have a couple of questions that are coming in. First of all, what is the basic difference between delta and delta live tables?
Yeah, I'm going to touch about delta.
Okay.
Yeah, I have a section of this.
Okay. Then the second question is, do you recommend to activate spot instances in the cluster configs?
Yeah, it depends on what you're going to do. Spot instance is really cheap, but it can just die in the middle of your processing. So if you're playing with Spark, if you don't care, you know, that your cluster is dead and you need to spin up the new one, yeah, sure. It's much cheaper to use spot instances.
Okay, thank you.
This is the data that I have generated. It looks like the table, okay, with all kind of columns. We're going to talk about what is data frame later, but it looks really like a table, and we can display it and see the data. Databricks has a lot of visualizations where I can, you know, really in a simple way visualize my results, and there is an option to build the dashboards with all kind of graphs. Well, it's still, well, it's not really visualization layer. You shouldn't use Databricks as a visualization layer. Please use Power BI or Tableau or whatever proper product for data visualization. But for data exploration, you can sure enjoy these easy visualizations that Databricks provides on the top of your result set. Okay, and here I'm going to generate another data frame with two columns, country and value, and this is nice visualization that Databricks it knows that the data set that I'm using and suggests me to visualize it using the map, the world map. Okay, so that was the first demo. Any questions on the first demo? This is really just intro the Databricks, a few features, how to use it.
Currently, no questions.
Okay, good. Okay, second demo that I wanted to show you is an ability to use data files stored on the data lake, Azure Data Lake. Okay, so you see I have a markdown here, title of the notebook. Okay, this notebook is in SQL language. The previous one was in Python. This one is SQL. So all cells by default will be SQL unless I state that specific cell I want to run in Python, and I will use Python Magic, just as I use SQL Magic in the other notebook. Okay, I'll create a database in Databricks. This is not real database, right? It's a data catalog. It's definitions. Okay, but you can use it and almost as you have databases like in product like Oracle or SQL Server. Okay, now I can create a table. I would say that it's Parquet file, and here is its location. I have here the script. By the way, this is the way to add code to Markdown cell, so you would see it as a code. And this is the way to mount the data lake container. Okay, you will have access to all those notebooks, and this is just, you know, you put here Azure container name and Azure storage account name and the key, and then you will be able to use this as a mount to connect to a table. So I have one table in my new database, yellow. I'm using the free data set for New York Taxi. I really like it. It's available for free on their site, and there are all kind of data, both Parquet and CSV formats. So I'm saying that I have here the files in this. This is container, and this is the folder inside container. One table, and this is the fact table. Okay, and another table that I'm going to add is taxi zone lookup, and it's stored in CSV, and there has a header, and I say, yeah, infer schema. Okay, so I'm creating two tables.
In the meanwhile, Maria, we do have another question as well.
Yes.
If there is a need to connect to Databricks Delta tables, do we need to connect via JDBC or ODBC, or can we also connect over REST API?
You can JDBC for sure, but most of those tables reside. There is no data actually in Databricks. You see, I'm creating tables on the top of Parquet file and CSV file stored in the data lake. So you can just connect directly to them if you want to connect from outside. Okay.
Okay, thank you.
Databricks catalog is it is available for BI tools for connection, and there should be a ODBC or JDBC connector. Okay, so after I have created files, I can, join them just as you would do regular join in any database. And you have, very rich language that supports the latest ANSI standards and all kind of window functions and CTEs and whatever you want. Okay, so here, this is my join, this is my data. I have borrow from where taxi started, which zone, how many trips I had, and total amount of money that was paid. And I also have here, it's just edited. It's not really meaningful query. I just wanted to show you the ability, to process SQL language. So I added here the row number function just to show that it is supported. Okay, and you can, do all kind of visualizations as we did in the previous demo. Okay, so that was work with the files on the data lake storage account. In the next demo, we're going to talk a little bit more about Databricks features, and then we will see how we connect to SQL Server and how we insert the data from Data Lake storage, okay, from Azure Container into SQL Server. All right, so that was a little bit from how the Databricks workspace looks like. And okay, now you would ask where Databricks fits in, because there are a lot of tools in Azure that can do similar things. They can do similar functions. Like according to Azure, this is the Azure screenshot. According to Microsoft, well, for orchestration, you would use Azure Data Factory to ingest data from Event Hub and store it into Azure Data Lake Storage. Data Lake Storage, it will house all data of all types. And Azure Databricks can be used, and I suggest you to use it, to utilize it to prepare the data, to enrich the data and train data sets. So you would use it for transformations, okay? After your transformations are ready, you can return it to the data lake storage, as we saw in the medallion architecture, to some higher category, like silver category or gold category, and then it can be served from Synapse Analytics. And of course, Power BI is our favorite analytical reports and dashboard tool. Microsoft is trying to now to put into each feature and all kind of abilities, like Azure Data Factory also, besides ingesting the data, also can prepare and transform the data. Databricks can ingest the data and visualize it. Okay, Azure Synapse Analytics can process the data using built-in data factory pipelines. And Power BI also can, connect to data sources, take the data files and merge them, merge data sets and visualize it. It doesn't mean that we should use one tool to do everything as we used to do in the early days. The monolith era is over. We need to check each product and see where it can do the best, okay, and combine existing services to get the perfect architecture. So if we take a look at all kind of areas where data engineer should be familiar and have tools, in data processing frameworks, there are a lot of tools. And what I want to show here that Databricks takes the best tools from each category. It utilizes Spark from data processing frameworks that you might use. It utilizes Delta Lake from Delta Lake category. You have here, it doesn't really play well in visualization, but in notebooks, okay, it is sort of evolution from Jupyter Notebooks, and from orchestration tools we have MLflow component, and that from data catalog area, Databricks Unity. So it's sort of, taking care of different areas. But again, as I said, you don't have to build monolith. Check all competitors, and you should just exactly know what are your requirements, and then check each tool against requirements. But sometimes it's really comfortable to have everything built in the same tool.
Maria, we have a couple of questions. First of all, is Delta Tables compatible with all the family of storage accounts like Gen 1, Gen 2, and Blob?
Sorry, I didn't understand the question.
Is Delta Tables compatible with the storage account Gen 1, Gen 2, and Blob? Or is it only Gen 2?
No, I think Gen 2 with hierarchical storage.
Yeah. Okay, then the second question is, if I want to use notebooks, I can go for Databricks standalone, or also within Synapse, of course. Do both have a similar life cycle?
They have a similar predecessor, like parent, Jupyter Notebook, but each company is just taking the notebooks, to whatever they want. They have really different features, Synapse notebooks and Databricks notebooks. They are similar. Every product now, every product that is processing the data has notebook inside. It's became some kind of standard. Data IQ, and even I think SQL Server new tools have a notebook inside. But it's different tools. It's similar but not the same. But if you know how to work with one, you will be okay with any other.
Okay, then one last question. Can Unity Catalog be integrated with Azure AD or user management, or is user management in-house of Databricks?
It can be integrated with Active Directory, that's for sure. And for a second, I'm not sure. Need to check.
Okay, thank you.
All right, so we finished talking about Databricks platform, and now we will talk about key features of Databricks. So the main feature that is really, that data engineers and data analysts really like is SQL analytics. Because as we saw, we have SQL native workspace, we can write queries in our familiar language, and there are query performance optimizations and execution plan and advanced visualizations on the top of query result, as we saw in the demo. Another thing that is really nice is languages support. Besides SQL, we have Python and Scala and R and Java, and I can have notebook in whatever language I prefer. Or I can mix, as you saw, we can mix languages in the same notebook. You can just, each multiple. Another great thing that supports streaming. It can be a real-time processing engine. It has exactly one processing guarantee, and it has ability to express computation on streaming data, and results are continuously updated as streaming data arrives. Native storage connections is another great feature, is optimized connection to Azure storage, fastest possible data access. Of course, if you are on AWS cloud, you will have native connection to S3 and the same on GCP platform. Serverless computing, as I said, is a new feature. You have instant server in 15 seconds, no wait for cluster setup, no over provisioning and idle time. And what I need to stress out here, that nodes are dedicated, like when you using the platform after a query is over, the nodes are being deleted and not reused, which is why it's considered really a secure tool. Strong security, fine-grained data access control, column level encryption, and access audit to satisfy standard compliances. And we go to the third demo now. All right, so, okay, this is demo. This is an example how Databricks can move data between different systems. Okay, I have here the connection to SQL Server database using JDBC connector. I am defining the variable which will hold the result set. I'm using Spark connector, and I'm currently in Python cell type. I'm using Python cell magic, but I really like to write SQL queries, so I would create temporal view on this variable. Okay, from this variable, I call it SQL borrow, and then I will be able to use it in SQL language cell. Here is the table that I'm connecting to, option DB table. I'm using URL, and the driver is Microsoft JDBC SQL Server driver. Okay, when I run it, what I have here a definition of variable that contains connection to the data set that I want. Now I'm going to access that data set, and the table is empty. This is my server. This is an SQL server that I'm connecting to, and the table is empty. As you remember, in the previous demo, I have created the table on the top of CSV file with a list of taxi zones. Okay, and it has, location ID and borrow and zone and service zone and all kind of data. Okay, what I'm going to do, I'm going to insert data into SQL Server using SQL by, using our regular insert into SQL select statement. Okay, so now I can go back to SQL Server and check if the data arrived, and it's here. However, if I want to update the data, I get an error because I can update the Spark data frames, allow me only append only operations. And if I want to update the data inside SQL Server, I will use different data connector, not Spark. Okay, there are a lot of libraries in Python how to connect to SQL Server, and we will just use something else. So here, Spark is we're not able to use Spark connector, and because it only supports Delta sources. As I said, Delta Lake is the Parquet files with transaction file attached to them. Another cool feature that I don't think any other notebooks I work with have it. Maybe Jupyter does, but I'm not sure about Synapse. It calls widgets. Okay, I can create widget dropdown. I will run it. You will see how it looks like. This is the dropdown widget. Okay, and I said I can do here, like, you know, artificial select, or I can go to a table and bring values from there. And I have here the same values that I have in this borrow table, okay, that we have in the Databricks. I will remind you, this is actually CSV file that we're looking through Databricks. So I've created the widget, this drop down, and then I can filter the table using widget as my filter. Again, this is the feature for collaboration, for data exploration. Of course, this is not like for building pipelines, but it's a nice feature and I really wanted to show it off. Now, if I use it inside SQL, I will need to rerun the statement every time I change the location. Okay, it's not changed automatically. But if I'm using this widget from Python cell this way, okay, if you remember, this table is built on the top of this data frame. I will show you again. I have created here a data frame called zones table, and SQL borrow is alias for this data frame. So if I come here and I say, show me this data frame, show me those locations, and filter borrow column by this get argument from the dropdown, I will also get results set. Okay, but what is different here, when I change the widget, it automatically refreshes the data. So it's really it's nice from my point of view. Okay, this is a nice feature. So this demo have showed us how easy using Databricks to move data from data store to data store. We could also compare data. We could join the data sets just to see what is missing. Let's say inside SQL Server and exist in, you know, in tables. We can do it not only with tables, but with any other system like Cosmos DB or Elasticsearch. I can join data from Cosmos DB to Elasticsearch to SQL Server to compare the data sets. This is where I see a lot of power this feature, this tool brings to data engineers.
Maria?
Yes?
We have a couple of questions. First question is it possible to work with Visual Studio Code and run programs from Visual Studio Code without having to open a notebook?
I haven't worked this way, but I think there was a feature a couple of months ago that you can connect to Databricks from tools like PyCharm and any other development tool. I haven't used it. I need to check.
Mm-hmm. Okay.
But then I think there is ability now to do it from, you know, from tools and not from the. What I did, I had the script in Python and I worked on it inside PyCharm. It was in GitHub, and Azure Databricks, as I said, is using GitHub as its version control. And the workflows, we saw workflows is the ability to schedule notebooks to run. workflows can take the notebook from GitHub from any branch. So this way, if you're using GitHub or GitLab or whatever Git you like to develop your code, then Databricks can automatically run it for you. Okay, so this way you won't need to enter Databricks platform, but you need to know how to, how to write the code. They have a little bit differences in the structure. Okay, but it's easy, so you can do it. Yes.
Okay. Then a second question that was asked is data profiling possible in Azure Databricks notebooks?
Data profiling, what do you mean by data profiling? Debugging?
I will ask to clarify.
Yeah, so I'm not sure.
Meanwhile, maybe a third question. Does coding in Databricks are just in notebooks? Can we not use object-oriented code base for Spark projects, like importing helper functions from other classes and other files as well?
You can do whatever you want inside Python cell, anything that you would do in regular Python, and it will work. You don't have to use Spark. You can just have Python code there, but what will happen if you're not using Spark, then you will not utilize the whole cluster. You will utilize just one node from the cluster, because regular Python code is not being, executed on multiple machines. Like if you're using pandas, for instance. All right? So you will need to build cluster with one node, but with, a lot of resources to process this regular Python code, which not utilizes Spark. The only way to utilize the whole cluster to use Spark and PySpark. Okay, so we're now in the section of typical scenarios for you, where you would use the Databricks and Spark. The first and most obvious scenario is streaming data, IoT, and real-time analytics. Like when you're using Event Hub or IoT Hub to ingest rapidly arriving data, can be millions of events, sensor updates, and then Spark would, create calculations on the top of that data, and you can visualize it in Power BI. This is one of the scenarios. Another one is visual data exploration, like when you have non-experienced users that want to do interactive analysis on the files. Just, to take a look and explore and, collaborate on what is in some new files that arrive from the customer, as I said, for non-experienced users. And they can do it directly from Power BI. There is a connector in Power BI to Databricks. So it is not that I just need to, I put here this placeholder. Maybe I should have put it in red, but it's in blue now. Spark is not a replacement for traditional data warehouse. You shouldn't build data warehouse this way. This just complements company data warehousing by allowing non-experienced users to, to take a look at the raw data. Maybe not raw data, but data that's stored on data lake. Another scenario can be interactive queries on big data, like when you have a notebook and you can access the data in Cosmos DB or in Elasticsearch and query it using native data access APIs. And you can do all kinds of advanced analytical algorithms. I have, in the previous client that I worked with, I had to pull the data from Cosmos DB to do all kind of, grouping and joins and the things that I wouldn't be able to do, in Cosmos DB UI. client. So it was really useful, and also, you know, working with Elasticsearch is not always straightforward, although now they have SQL language, but you know, you can do it inside the same platform ready. So whatever database you have. I also used to pull data from Jira, you know, and to aggregate all kind of tickets in some weird ways that that analyst wanted to see. So you can do whatever you want with whatever data store that you have. Even GitHub, you can connect to GitHub database. It's sort of graph database, and pull all commits and branches and just do, you know, analysis if you want using Databricks. And I did it in some project. I pulled the data from Jira, pulled the data from GitHub, and then merged the data to produce some report that one of the management wanted. And of course, machine learning. This is the most obvious usage of Databricks, and everybody's talking how it's great for, you know, machine learning. You can store big data sets, process them in memory. Great. It has great performance for iterative queries common in machine learning workloads. And you can use all kinds of machine learning packages that are available in Python or in R. This is really nice architecture example that I really like, and there are many things that I like about it. But first of all, it sort of isolates our pipeline into small tasks, or not dependent one on the other, because you see here multiple Databricks packages. Each one is taking care of the specific task. They have different schedule. They don't, one failure or errors in one doesn't impact failure in another. And this is, I think this is the great demonstration of modern pipeline, which is not doing everything from the beginning till end as we used to work like 10 years ago. You will have different multiple pipelines that are each working on its own schedule. This is the first thing that I like about this pipeline. Another thing is that it shows that Databricks has, as I said, a lot of connectors, because you can use Python. Okay, and for instance, Twitter is not really easy database, you know, to connect to. Not everyone can connect to Twitter. I don't think that Data Factory can connect to Twitter other than using Python in it. So, but here, you know, it's also sort of show it's also Microsoft screenshot that they're showing if you need to connect to some weird data set, you just use Databricks. Okay, and you know, on each iteration, I don't know if you can see my mouse, or maybe this way. On each iteration, the data is returning. Here it's returning to Event Hub, but it can be returned, as I said, if we're using Medallion architecture, it can be returned to Data Lake. And there are all kinds of users for each stage. All right, any questions? Or we continue?
No question at this moment. No, the question that was previously asked was clarified, and it actually was data profiling. The question actually was, would you use a Databricks notebook to quickly examine, analyze, and create useful summaries of data?
Yeah, that's what it is for. Exactly. So we talked about Databricks platform, we talked about features, and we talked about typical scenarios. Now I'm going to, you know, go to the data frameworks and a little bit of how Spark is working with the data. Just a second. Sorry, someone is talking here, and I'm sorry if you can hear all the voices in the house. All right, so now we will talk about Spark SQL model that meant for structured data processing. A data frame is the data structure that organizes the data into two-dimensional tables of rows and columns, just as the tables that we used to work with. Every data frame contains blueprint known as schema that defines name and data type of each column. And data frame can span a lot of files. Like we look at it and we think that it's the same table, but it's not. It can be multiple data files. Okay, it serializes data in memory and has SQL query access, SQL style query access, and schema auto discovery. Spark automatically partitions the dataset and distributes the partitions across different nodes. Every machine in Spark, when we start processing our dataset, will have one or more partitions. Okay, here we have a cluster of 3 machines, and each of them will have the third of the data that I'm asking to process. Partitions in Spark do not span multiple machines, and if we use partition by feature improperly, we might end up with a partition, unbalanced partitions. Okay, it's called partition skew, where you have, like, if you partition the data by country and there is a United States data and the data for other countries, then you might end up with unbalanced partitions, and this is called partition skew. So you need to think how to partition data. Apache Spark data frames provide a rich set of functions like select and filter and join and aggregate, just as we would have in the tables. I'm sorry, I just need to. I'm sorry, I'm back. So that all kind of functions, just as we would have if we would use SQL language. Transformations are functions that define what we want to do with the data, and we have actions that define what we want to do with the result set. As you see here, in this example, I am creating the variable, okay, data aggregated, and I'm defining in my data. I want to group it by some field, and then I want to count, from this column and rename it, and I want to select only columns, cluster name, and the column that have got out of aggregation, and I want to order it by some column. There is nothing happened after I have executed it, because the Spark lazy evaluation, which means non-operation is never computed until action is called. A lot of people say, the Azure Data Lake storage is working so slow. I create a query and it's running in few seconds, but when I want to save the data to Azure storage, it's suddenly taking so much time. Why Azure storage is working so slow? And they just don't understand that nothing happened until they called action to save the data. So this is something is really important. A lot of people are missing it, and they don't understand how the query is in Spark is executed. when action is invoked, when I say show me the data or calculate count of the data set or save the data, then the job, the Spark job is launched. On each executor, there is a task running and doing the calculation. If you take a look at data frame execution against Spark SQL execution, you will see the difference. Here, this is the same example from the previous slide. Like, we don't have any job launched. Spark didn't do anything. It's just defined that I will have this variable data frame with 2 columns. Okay, and it knows the data types because the data types are available as a part of data metadata. But when I call data aggregated show or display, give me the data, then you see the Spark jobs are launched. If we take a look at SQL execution, because select is a part of the query, we immediately have Spark job starting to work. If we go back to the demo, to the first demo, where we had, for instance, this data frame of the, the countries and some values of something. I'm defining variable and I'm generating the data. If I run it, nothing happened. Okay, I just have this definition of the data frame here, but Spark didn't work. And the same thing can happen if you're running a huge query, and it's just, it's really fast. But if I want to display only now, well, here I'm generating the data set, okay? But if I would use the data file, only at this point, only when I hit display, the Spark would go and read the data. Each node would read the part of the data, okay, and process it in memory and return to me. This is why this operation would take much longer than any query that you would write. Okay, I hope it's clear, because it's very important to understand before you're starting to use Spark. And there is some expensive disk and network I/O is happening, and need to understand how the data is processed. Like, the mapping operation identifies which records belongs to which group. Let's say if we have 3 servers, as we have in this example, each server will read its part of the data. Okay, and the keys are aggregated across partition. Okay, they are mapped. So let's say here each color represents the different country. After they were categorized, the records will be written to disk. This is called shuffle write. Okay, shuffle write. And then each server will pull the data for its countries that are supposed to be in the partitions that is going to take care of it. So here, each server will pull the partitions from the disk. It's shuffle read, and then the records will go through some kind of reduce operation like group by and count, and then we are getting a result. So this is also kind of important to understand how data is being processed. Okay, you need to avoid, or let's say minimize, the shuffle, to get faster performance. And mitigation is usually like, you don't create 100 machines, just have a few larger machines, then they will be able, each one to get the partitions properly, and will not need to do a lot of shuffling and moving the data from cluster to cluster. keep data pre-aggregated in your medallion architecture. You know, keep the data sets aggregated, and then you will need less shuffling in the upper stages, in the upper pipelines, and use filtering and use less columns, just columns that you need, and filter out unnecessary records.
Maria?
Yes?
We have one question about data shuffling. What size of shuffle do you recommend, since the default is 100?
I don't recommend any shuffling. Start with the defaults, and then, you know, you see how the query is running and take a look, you know, how many. We have the Spark job execution plan, I think, in the next slide. And you can, you know, you can just analyze the execution plan to see how long shuffle is taking, and then, you know, to adjust. It's just so depends on your workload. Okay, depends. But in general, you will have, regardless if you're running data frames or SQL engine, at the end is just exactly the same execution plan is generated, and the data will be parsed exactly the same way. So that you don't need to, if you taking the data frame and, you know, changing it into SQL statement or vice versa, you wouldn't usually improve performance by doing this. Okay, so execution plan will be exactly the same. That's just an interface to Spark. But at the end, it's working with data frames.
Mm-hmm. There has been asked another question as well. Does the shuffle action affect the count of files on writing?
Shuffling is between the map and reduce. It's not. You will have, like, if you have, as far as I understand, and if as far as my experience goes, if you have three servers in the cluster, you will have at the end 3 files. Unless you say, I want to partition data, because you can, before you're saving the data, you can say, I want to partition data by any column, like country, okay? And then you will have number of files as the number of partitions that you have. Or you can say, build 100 files for me at the end. It's just, you know, you can use it. You can configure it, okay? It's not connected to the shuffle, because shuffle is between stages. It's not at the end. As you see here in this execution plan, we're reading the CSV file, and then we have pre-aggregation, and then exchange is a shuffle. Okay, we you know, it's writing the data, and then it's reading the data, and another aggregation, the final count, and then we have order by, and then project. Project is select, actually, is happening at the end. Okay, it's a nice execution plan, and there's a lot of information in it, and you can just, you know, go and look at it. Okay. Yeah. So, another thing that I wanted to talk today and is the difference between procedural pipelines and declarative pipelines. Like most ETL frameworks perform procedural transformations. They're working row by row, applying data cleanup, enrichment logic, and we must explicitly state how to get the data and process the data on the lowest technical level. We need to break the work down to the smallest steps, like in this example. Declarative data processing is working differently. We don't need to define the order of data transformation logic, and execution does not require explanation, okay, of every step. And when we use declarative approach to process data, execution timing and pipeline complexity are significantly reduced, just as when you compare SQL query to some cursor, okay. So this is the difference between, you know, IDF, data factory, and that delta life tables, which is the nice feature that someone asked at the beginning of the session. It's innovative Databricks framework called Delta Life Tables, and it's dynamic transformation tool similar to materialized views. Okay, so what we have simplified pipeline that uses data as a code style. So Databricks is taking care of finding best indexation plan and managing cluster resources. We only define queries. And if you see here, this is, I can show you this notebook because it's really small. Delta Life Lake. Okay. So we define streaming live table, and besides connecting to the data file, I would also define constraints, the quality rules that I have. I would say I have valid number of passengers, and I would say, you know, what I'm expecting to have in the column. And if I have violation, what I want to do I want data frame to drop the row or to do something else. Okay, so I define one table this way, and I define another table, and then I create, this is as we call materialized view. Okay, this is a query, okay, which becomes delta life tables, is being updated automatically. Let me see if we can. This is it's already running. Okay, you can see it this way, and it's being updated. I automatically get this visualized. All right, I didn't do anything. All I do is I just defined 3 queries, and then Databricks take care of everything. Here on this screenshot, we can see that we can click on each table at the end of the processing and see how many files drop, how many rows written and drop, what is the statistics, the expectations, and the number of rows. This is delta life tables, and this is the declarative ETL that it is innovative Databricks framework. I hope it answered the question that we had in the beginning, the difference between Delta Lake and Delta Life tables. Okay, Delta Lake, Data Lake is just a pile of files. Delta Lake is a framework which attaches to each file at execution, at a transaction file. And Delta Life table is sort of materialized view in memory that you can query without, and if anything changes on the one of those tables, the changes automatically are being propagated to the upper tables, like concept of data table chaining and reuse. All right, so this is the Delta Lake, and we saw the demo already. I showed you the UI and all kind of best practices. You need to make sure you know that you limit cluster resources, not to pay too much money, because that's the different clusters, the clusters that you're using for the rest of your code. You should store expectations, store those data quality rules somewhere, in GitLab, in some kind of format that can be shared, and save invalid data instead of dropping it to analyze later. Okay, so thank you for listening. Thank you for listening, and if you have any questions, I will be happy to answer.